Welcome to the first webinar from Stinson ITS this year. We hope that you had a really good vacation and we wish you all a very, very happy new year. So by now, most of you know that we present a webinar at 1 p.m. EST on the first Wednesday of each month. The topic for this webinar is Intelligent Warning System. I am Ajay Kaushik, Technical Sales Director at Stinson ITS, and I'm based out of Ontario. I also have my French-speaking colleague here with me today, Michael Mondor, who's our Technical Account Manager. He's based out of Quebec. So the agenda for today is very, very simple. We'll first talk about what makes intelligent warning systems intelligent, and then we'll cover 4 different intelligent warning systems, starting with intersection conflict warning system, overheight warning system, emergency vehicles warning system, and curve warning systems. And finally, we'll take questions from all of you. We request you to ask your questions in the chat window, in the questions window, not the chat window, during the presentation, and we'll answer them immediately at the end of the webinar. For the first time this year, we have 2 quiz questions at the end of our presentation, and the first 2 correct answers for each question will get a small gift hamper from us, which will just have a notebook and a Stinson ITS coffee mug sent to you guys. So, listen carefully and be ready to answer these questions. And please answer the quiz questions in the chat window. So the questions in the questions window and the answers to the quiz in the chat window, please. So that's it. Let's just get started. Michael.
Yes, thank you, Ajay. Good afternoon, everyone. Thank you for joining this webinar. First, we're going to talk about intelligent warning systems, how they're built, how they work. First of all, any intelligent system is broken into 5 subsystems, if we can call. These systems are power, sensing, activation, connectivity, and monitoring. Power, the most common source of power for an IWS system is solar power, but we can also use, in some cases, 120 volt AC from street light or power grids, and it may not always be active all the time. So in these cases, we're going to be using 120 volt AC to recharge batteries or UPS mode batteries during the night and run the systems on battery during the day. But because the IWS system or the intelligent warning systems from TAPCO are designed to use very low power consumption, they usually will last for several days beyond without being recharged, I should say. Now, the sensing part, we can either use radar detector, magnetic detector, inductive loops detection, or infrared detection. Detecting equipment has to be as accurate as possible, but no matter what type of sensing device are used, they need to be positioned properly to provide timely activation and to provide accurate detection. Timely activation is also very important. Intelligent warning systems all serve a common purpose, and it's to warn drivers of dangerous situations that they may have to face on the road ahead of them. Depending on which intelligent warning system is used, the message to the drivers will be displayed using either flashing beacons, LED signs, blinking LED signs, or direct short-range communication message, most commonly called DSRC. The physical location of these warning devices is in most cases critical and needs to be positioned to allow for sufficient time for drivers to properly react to the warning message. Now, the 2 most important subsystems of any IWS system are the sensing and the activation. Connectivity is also important. Most systems have the capability to send activation message to ATMS or third-party systems. This is normally achieved by using internet connectivity, 3G or 4G cellular modem connectivity, or application programming interface, most commonly called APIs. Now, the monitoring part, any efficient IWS system should provide the capabilities to store and monitor the data, analyze it, and provide visual aids to help the user to analyze the data. Now, Ajay will now talk about the very high efficiency of the intersection conflict warning systems. Ajay?
Thank you, Michael. So the first intelligent warning system we are covering is the intersection conflict warning system. It's a very, very simple system. It detects vehicles using a sensor such as a radar or an inductive loop, usually on a minor road, and then warns vehicles on the major road, or warns drivers of vehicles on the major road using flashing beacons or LED signs. It is ideal for use at unsignalized intersections or two-way stop intersections, especially when there are visibility issues. Can you hear me? Sorry.
Yep.
So, especially when there are visibility issues due to vegetation, road geometry, or structures. It's also very useful if the intersections have specialty vehicles crossing it, such as slow-moving farm vehicles or even construction vehicles. So as mentioned by Michael in the previous slide, the most important design aspect for designing an intersection conflict warning system is to ensure that enough advance warning is given to the road users so they have time to react to the situation and will be a little bit more careful. It is absolutely important to not only selecting the right type of sensor and warning activation mechanism, but also to ensure that the sensing is done at the right location and warning signs, whether they are flashing beacons or LED signs, are located at the right location on the roadway. So not only these systems are more cost effective than signalizing the intersection, but they're also designed to be autonomous with solar power, backup batteries, and wireless communication equipment. All in all, cost effective, very easy to install, and very reliable. Now, Michael is going to talk about override warning systems.
Thanks, Ajay. Override warning systems is essential in cities and on roads where reduced height structures, such as low bridges, low-hanging cables, are present. In order to reduce or eliminate risk of collision between overhead vehicles and reduced height structures or objects, these systems have to be installed well ahead of the structures to allow for overhead vehicles to be detected well ahead of the danger. Warning devices used to interact with drivers can be flashing beacons, LED enhanced signs, VMS or else. The activation of these warning signs or warning devices must happen between milliseconds after the overhead vehicle is detected to give the driver sufficient time to react and to veer off the road by using the escape route, or what we commonly call the bailout route. Okay, physical location of the override sensors and warning devices is calculated according to the speed limit in the zone where the equipment is installed. So the installation is critical in this case. Detection devices consist of dual beam infrared sensors located on either side of the traffic lane. The use of dual sensors allows for directional detection. When the infrared beam of the sensor is interrupted by an overhead vehicle, a signal is sent to the remote blinker sign or beacon by radio communication to activate it and to warn the driver not to proceed under the structure and to use the escape route to avoid a collision with the structure. At the same time, a cell modem can be activated to send a message or SMS or an email message to a local authority to warn them of the situation, and also a picture or an image of the vehicle and the license plate can also be taken using a camera, and that image can also be sent to the local authorities for future reference. Now, Ajay will talk about the effectiveness of the emergency vehicle warning systems. Ajay?
Thanks, Michael. So emergency vehicles warning system, they're also very interesting, and I'm surprised that we don't see so many of them in Canada. They are very popular in the US and are ideal for use in front of fire stations, police stations, emergency services, stations, and hospitals. Depending on the individual needs of the location, we can provide push buttons, automatic strobe detection, or even wireless key fobs to trigger the activation mechanisms, which can be, again, blinker signs or flashing beacons. The wireless key fob is especially convenient if an emergency vehicle is returning back to the station in a hurry. These systems are not only important for preventing near misses and collisions near these emergency services, but they're also, they also save precious seconds for these vehicles to reach their destination. So these are very simple but very nice systems, and again, solar options and different power options can be provided based on location to location. Now, Michael will talk about curve warning system.
Thanks, Ajay. Curve warning system. Their primary function of the TAPCO dynamic curve warning system is to alert the road users of an approaching steep curve or ice-prone ramp, and to guide them safely through the curve with a series of highly visible enhanced warning signs, or warning blinker chevrons in this case. The blinking chevrons have been proven to be an effective device to warn drivers of the dangers up ahead. In fact, when vehicles are approaching steep curves or ice-prone bridges or overpass, a Doppler speed radar will detect their speed and will trigger the entire system. The blinker chevrons will either sequentially or simultaneously flash to bring greater visibility and to guide the road user through the horizontal alignment change. The system will turn off simultaneously after a preset time period from the last vehicle sensed. These warning devices can be activated either 24 hours per day, 7 days per week, or day and night activation, or only activated when a preset speed range is sensed by the Doppler radar. Now, Ajay will talk about the design aspect of these signs. Ajay?
Thanks, Michael. So now we have covered 4 different types of intelligent warning systems. There are others available as well, such as icy road warning systems. But in this webinar, we want to keep it very simple. And we also want to emphasize on the fact that all these systems are highly customizable as per the needs of the location or the needs of traffic authorities. We usually perform extensive site surveys and design consultations with specialist engineers. 2 of them from TAPCO are here with us today. In case we can answer your questions, we would ask them to help us. So before we come back to you with a proposed solution, we usually go through a lot of these steps to come up with a really good solution. And these steps involve understanding the problem and the application very well. So depending on what type of warning system do you want, we usually go to the site, understand where the collisions are happening, what is the core problem, where do we need to do detection, where do we need to do warning signs, what are the locations where we can put it. We do all this in the site surveys, especially if solar power option is selected, then and usually we see a lot of our customers go for solar power options because then it becomes completely independent of existing systems. It becomes very autonomous. So we have to go to the site not only to see, in winters how many hours of sunlight would be available, but also to see if the sunlight, even in winters or in summer, is going to be blocked by trees or structures adjacent to the location. So we find out what the right power source is around there, whether it's AC light, whether it's street light, what kind of solar panels should be selected, what capacity of batteries should be designed. So we do a lot of these design considerations, and and it's very important to understand what is the right type of sensor that we install there to detect the danger, and the right type of activation mechanism. Again, activations could be a standard in different provinces here in Canada. Some provinces like beacons a lot more than blinking signs. but we have found both of these to be equally effective. And it's not just finding the right sensor and the activation, but it's also installing them at the right location, which could be, again, based on the road speed, for example, or the road geometry. So we do all these site surveys, we do a lot of engineering before we come back to you with a really nice solution. Last but not the least, in today's, we see a lot of customers at least talking about connected vehicle interfaces. Most of these systems are today designed for drivers, but all of these warning systems from TACPO, they are upgradable to connected vehicles system standard, especially the DSRC radio. So they're all future-proof. In case you need them in future, we could always upgrade these systems to a connected vehicle system standard. So I feel that's probably the end of our core presentation. We'll give you some time back later, but we're going to go to the quiz now, and Michael will take care of the quizzes.
Thanks, Ajay. So now it's time for quiz number one. Like Ajay mentioned at the beginning, please write your questions on the chat portion of the chat on the right hand side of So Ajay, if you want to bring the question.
First question.
What are the two most critical aspects of an intelligent warning system? Is it A, low power consumption and accurate sensing, or B, accurate sensing and timely activation, C, internet connectivity and remote monitoring, or D, timely activation and remote monitoring? We will wait about 15 seconds for participants to write their answers. Okay, so I think we should have all the answers from all the attendees. The correct answer in this case for quiz number one was B, accurate sensing and timely activation. Now let's move to quiz question number two. Question number two, what type of sensor do we use for overhead warning systems? Is it A, single beam infrared sensors, B, dual beam infrared sensor, C, dual LiDAR sensor, or D, dual beam ultrasonic sensor? Once again, we'll wait about 15 seconds for answers to come in. Okay, it looks like everyone has answered this question too. In this case, for quiz number two question, the right answer was B again, dual beam infrared sensor, like we mentioned during the webinar. So now, following all these answers, we'll wait for Samantha to compile all the results, and we'll let Samantha announce who the winners are.
For the first question, the first two people to answer right were Bruce and Tahir. So we'll send you an email to get where we should ship your packages to. And for the second one, it is Glenn and Mark. So you'll be contacted afterwards so we can find out where to send your mugs and notebooks.
Great. Thank you, Samantha.
Okay. So, right. If you have any questions, please type them in the questions window. The first question that I have is what is DSRC radio and how is it used for connected vehicles? You want to answer that, Michael, or should I answer that?
Please answer it. I didn't get the question.
How is DSRC radio connected? What is DSRC radio and how is it used with connected vehicles?
Can you answer it?
Oh yeah, sure. So DSRC radio is just an interface. It's a digital communication interface. It's a short range communication. It works up to 300 meters. So usually there are these roadside devices. For example, it could be this warning system. Maybe it could be intersection warning system here. It detects that there is a vehicle coming and it sends a DSRC message to the connected cars. The connected cars have the capability to understand the protocol and get this message over the radio communication, the DSRC radio communication. I think the frequency is something like 7.8 gigahertz, something like that. I'm not sure about the exact frequency. I can check that and send you an email later. But the vehicles can process this message and get warned about an oncoming danger, and they can take evasive action or they could be ready to brake, something like that. The next question that we have here is, have you done bike lane crossing driveway warning signs? And hold on, let me just drag this to see the whole question. How do you detect bikes in this application? We haven't done that yet, at least in Canada. And we can check with our TAPCO friends. If they have an answer to this, we'll get back to you tomorrow or probably by the end of this presentation. The next
Jason and Justin are online from TAPCO. I've unmuted you, so if you have anything to add, please feel free.
Yes, guys, can you hear me?
Yes.
This is Jason. Yes, we do bike lanes all the time. They can be activated by a number of different measures, from FLIR, thermal sensing, to pedestrian, just motion sensors can be implemented within the bike path further down before they cross the intersection. You can also use the loops as an activation as well.
Oh, perfect. So I hope, Len, this answers your question. And if you want more details, please send us an email and we'll send you the details later. So Mark has the next question, which is, are you working on any new ideas for sensing? I think TAPCO has about 10 or so warning systems, and they always keep working on new ideas. As long as there's a challenge which can be solved using a warning system, they're happy to solve the challenge. Do you have anything to add there? Brian, sorry, Jason or Michael?
Not to that question, no.
No, not to that question.
Michael, this next question is for you.
Yeah.
Who are your local distributors in New Brunswick?
Yeah, this question is from Mark. Mark, I'm the local rep for Eastern Canada, which includes Quebec and the Maritimes, or New Brunswick and all this. So after the webinar, I can send you my my contact information if you want to give me a call, or I can send you an email or give you a call if I have your phone number.
Okay, the next question is from Bruce, who's asking, are your signs MUTCD compliant? Yes, all our signs are MUTCD compliant, and even before we manufacture them, we design them and show to you, take your approval before we actually manufacture them. That's a part of the whole process. Do you want to add something to that, Jason?
No, that just about covers it.
Okay. The next question is from Ethan. What issues and considerations should be considered for battery UPS systems in Canadian winter conditions? What kind of long-term operational and maintenance expenses would a municipality expect? Michael, do you want to go at it, or I can answer that?
Please answer it, Jay.
Sure. So in terms of Canadian winter conditions, we usually consider about 1.5 hours of sunlight a day for designing the solar system. And generally, we design the battery at least to last for 3 weeks, even without any, solar, any solar energy availability. So it's about 3 weeks without any kind of power, which is what we usually do for battery calculations. In terms of long-term operational or maintenance expenses, we have some of these systems installed for last 1 year. In fact, we have recently installed intersection conflict warning system very close to Toronto. I know I went there day before yesterday. I wanted to take a video for this particular webinar. I couldn't edit the video in time to get it in, but there's been hardly any sunlight from the last 2 weeks, and it's still working very well, just based on batteries. And generally, they have had no expenses. There's absolutely no maintenance that they have seen. But I guess in about 3 to 5 years' time, you'll have to change the batteries. And if there is any vandalism, you need to do that. But generally, the radios are very reliable. The solar power works very well, and the batteries last as they're designed. So anything else that you want to add, Jason?
Correct. What we'll do is we'll solar size the batteries and solar panels for every individual location to ensure proper autonomy to the system, obviously meaning that for prolonged periods of time without direct sunlight on the solar panel charging the system, those systems will continue to activate properly for long periods of times until it receives more sun to charge the systems. When we initially design these systems, if we have a questionable location, what we can do is send out what's called a solar survey kit. And in turn, what that is just a small tool that you can take pictures of a mirrored dome at the pole locations where the solar panels will be. You send in those photos, and then our engineers will run a calculation into our system, and that will determine the size of solar panel and battery package needed for proper autonomy.
Yeah, absolutely. In fact, you could answer the second part as well. What type of maintenance is expected for these typical installations? Because this is also a question from Terry.
Sure. As far as maintenance, a very low maintenance. Depending on activations of systems at the particular locations will determine longevity of the batteries. I've seen systems go as far as more than 5 years with the same batteries before they need to be changed out. What we do recommend is that each municipality perhaps implement a maintenance scheduled program where they visit the locations on a regular schedule and do a battery test just to ensure that it's holding its proper charges. But like I say, it varies from location to location.
Yeah, and usually there's very, very low maintenance required for these systems. That's a highlight that we sell anyway to all of our customers. Todd, I'm going to send you a personal reply, a personal email for the question that you have asked. And that's it. That's all the questions here.
There's one question I think that we've missed. Okay. Someone said he was 10 minutes late to the webinar. He wants to know which are the four types of product that we covered. So we covered the overheight warning system, intersection conflict warning system, emergency vehicle warning system, and the curve warning system, or the blinking chevrons that some people call it system.
Yeah, and we're going to send you a video recording of this webinar in an email tomorrow. So just in case you want to look at it sometimes later, along with, and this is my next slide. So please don't forget to register for the next webinar that we have from Houston Radar. This webinar is about radars, which is cost-effective and reliable method for traffic data collection. That's on February 3rd. Again, it's a Wednesday at 1 p.m. EST. The presenters are Casey Eno, who's the sales manager at Houston Radar, and Sherry Rowell, who's our account manager for Western Canada. So when we send this email tomorrow, you will have a link to register for this webinar. You will have a link to the recording of this particular webinar and a link to Michael Mondor's blog that he has written about these warning systems. So thank you everyone for your time today. We're going to give some of your time back. It was a sweet 30-minute presentation today. Thank you everyone. The next page has our contact details, mine and Michael Mondor's both. If you have any questions, please feel free to reach out to us. Thank you very much.
Thank you very much, all.